Hello and welcome to my Sprint 3 video. The first thing that I will address are the notes I got from my last sprint. As you can see in my game.cpp file, the game singleton no longer micromanages the other managers. All of that has been delegated to their respective managers. The issue is right here. It's gone. In addition, I've put debug messages in all of my base classes, added the proper virtual destructors, and as you can see in the output, I'll just run it to get a fresh output. I have lots of info about what is being deleted. These are all messages in the destructors for classes. So if we look at the frigate, we see that the frigate is beginning to be deleted, which means all of its alarm commands are being deleted, which were all in that alarmable object. The game object's being deleted, the drawable, the registration commands that go with that, the updatable, and the registration objects that go with that. So this whole big chunk is the one frigate being deleted, and I have the same thing for my suggest drawable objects, the scene, the camera manager, as well as the shader texture and module, the asset managers all get deleted there too. So that will hopefully help me keep track. I've already recorded a few versions of this video where looking in this debug window has helped me catch things, so that's very helpful. Moving on to the deliverables for this sprint. My scene class has a draw manager, an update manager, a registration broker, and an alarm manager. These are all multi-tins. Each scene has an instance of all of them, not shared between any scenes, and each of them have their corresponding lists, registers, process, commands, and other things that they need. If we jump into the, let's go to the drawable object. My drawable objects and updatable objects are registered initially in the constructor and deregistered in their destructor. I've done that for those two classes, the drawable and updatable, because as it makes sense to me that if something is derived from a drawable object or an updatable object, it is intended to be drawn and or updated. If the user wants to, for some reason, stop drawing or stop updating their object at any point, they are free to do so. I have some debugging messages and a little guard in both of those classes to make sure that they are properly deregistered before they are deleted. In the drawable manager, pretty simple. Sorry, I'm just trying to think of the best way to describe the process. When an object is being registered, it goes through its registration with state checking. The command is not created. Each object has its own set of commands. The command is submitted to the proper, or is submitted to the scene, which is submitted to the registration broker, which adds it to its command queue in the registration broker. Let's look into the scene. This is the scene update function, where at the top of every scene, the broker executes the commands, and then everything else, all the other managers, follow that one. Same thing for the deregistration. Where is it? Draw deregistration, which goes to the scene, which sends it to the broker, and when that command is executed, ultimately the final deregistration is called, and the registration state is appropriately updated. The alarmable is, of course, a little bit more complicated. My alarmable manager has a multi-map as its priority queue functioning container. Where is it? It's up here. There it is. There are enums for the alarm ID, so I have 3 operating alarms, and if we watch this output window over here, the frigate has 3 alarms going. Alarm 1 operates every 2 seconds, alarm 0 every 5, and alarm 2 every 7 seconds. So here they are triggering, and each alarm just toggles the blue sphere. So everything still runs. I'm giving inputs as far as the ship movement, but the alarms are triggering and having a great time. This one is only different in that it has the switch statement and the array access for each individual alarm. Each individual alarm has its own commands, which are set up in the constructor, and it is completely up to the user to both submit and deregister their alarms. There's checking for it, but there's no fallback. The engine does not do any of that for the user, and here is just the code for the alarms. Thank you very much, and I will see you in class.